In my previous video, I showed how to calculate tangent line to a curve. Now here we're going to do backwards. Line is given and curve is given, and we need to figure out whether this line is a tangent to the curve of that is given. Shortly saying, figure out if this equation, in this case 2x minus 1, is an instantaneous rate of change. And we need to find out this through derivative. Okay, so when we are talking about tangent line, we are talking about common point between that line and curve, right? Common point. What that means mathematically, that means it's a solution. Remember when we used to the solve system of equation and the point where graphs cross each other, right? That point is a solution. So accordingly here, we are going to solve these two equations. Y is equal 2x minus 1 and y is equal x squared. All right. So since both equations are equal 1 and same y, therefore we can insist that if the left sides of equations are equal, that means right sides also equal. From here we can insist that x squared is equal 2x minus 1. 2x minus 1. Okay, so obviously this is quadratic equation. We are going to solve it. X squared minus 2x plus 1 is equal 0. So we have x minus 1, right? Equals 0. Or it's a perfect square. It's the same thing if I would write down x minus 1 squared, because x squared minus 2x plus 1, it's a squared minus 2ab plus b squared, which is a minus b squared. Minus 2ab plus b squared, which is equal a minus b squared. Okay, so it's the same thing, or factoring down. Okay, one way or another, x is equal 1. So when x is equal 1, I'm plugging back to, let's say, this one, or either one. You can plug either first one or second one, and you get y is equal 1. Okay, so intersection is 1 and 1. This is the solution for these two equations. And as we can see, this is the only solution, right? There is no the second solution, which tell us that the line y is equal to x minus 1 is a candidate to be a tangent line to a curve x squared. Now we need to check to make sure that this is the tangent line. Okay, so what we are going to do, we know that tangent line of the curve is a derivative of that curve, right? So we are taking y is equal, y is equal to x. I'm going to take derivative, first derivative. It's going to be, no, not 2x, x squared. Instead of writing original, I'm writing derivative. Okay, 2x. Now let's compare. Y squared, y prime is equal to x, and y is equal to x minus 1. What do we see? They have the same slope, right? Which is 2. Even though since both equations have the same slope, I would hold back to insist that the y is equal to x minus 1, y is equal to x minus 1 is a tangent line to y is equal x squared, because it could be parallel line, right? Because parallel lines have the same slope, correct? let's say if this is our tangent, here is parallel, would have same slope. But this point, the fact that y is equal 2x minus line, 2x minus 1 has a common point with this curve, then we are insisting that with the same slope, we are insisting that y is equal to x minus 1 is a tangent line to our curve. These two conditions are satisfying same slope and a common point, and one common point. Okay, so there we go. To y is equal to x minus 1 is a tangent line for y is equal x squared. Thank you for watching.